Uniform demand or constant demand is what we have talked about in the last session. Eoq with constant demand. Part of inventory theory, we have done Eoq with uniform demand or constant demand. What was the formula? Q star is equal to root of 2dCO by CH. So D is your demand. CO is your ordering cost per order. Ordering cost per order. CH is carrying or holding cost. Carrying or holding cost per unit per period of time. Per unit per period of time. Okay, so this was the formula. There are different ways of looking at this formula. The one we will look in the previous session is also right. Same thing. Okay, so optimum number of orders per year. Optimum number of orders per year N star is equal to D by Q star. D by Q star. So total inventory cost. Total inventory cost denoted by TC star is equal to root of 2 into D into CO and CH. 2 into root of CO and CH. So total cost is equal to TC star plus cost of material. So cost of material. Let us say an enterprise requires 1,000 units per month. An enterprise requires 1,000 units per month. The ordering cost is $50 per order. The carrying cost 5% per unit per average inventory per year, the purchase price is 20 per unit. Find the economic order quantity and total minimum cost. Find the economic order quantity and total minimum cost. So there is a carrying cost is 1 plus 5%. So we have monthly demand and the other things are per year. So we have to convert monthly demand to demand per year, which is 1000 into 12. We got 12,000 units as the demand per year. Carrying cost, ordering cost is 50 per order. Cost of holding is 1 plus 5% of 20. That means 1 plus 1, this is your 2. So now replace these values in the formula and calculate. So Q star is equal to root of 2DCO divided by CH, which means root of 2 into 12,000 into 50 by 2. So this would be, multiply this, two into 12,000 into 50, 12 lakh divided by 2. This would be root of 6 lakh. So root of 6 lakh would be 774.59 or 775 units approximately. 775 units approximately.
So this is going to be per year, right?
Yeah, per year. Next, we have to calculate total cost. Total cost is equal to TC star plus cost of material. So that means TC star is root of 2 into D into CO into CH plus cost of material is 12,000 units into 20. This means this root of 2 into 12,000 into 50 into 2 plus 24 lakh. 24 lakh or 2,40,000? 12,000 into 20 is 2,40,000. So I made a mistake here. So this is 12 lakh into 2, 24 lakh square root is 1,550. 1,549. So this will be 2,41,549 approx. All right. All of you got this? See, basically we are expecting uniform demand. This is the whole calculation is for the thing to be uniform demand. Sorry, this is not uniform demand. We are looking at uniform demand. Right? All of you got this? This is your inventory level. This is your time period. Okay, should I move forward?
Yes, sir.
Should I move forward, participant?
Yes, sir. Done, sir.
Yeah. So now let us look at EOQ with different rates of demand, with different rates of demand in different cycles. So the economic order quantity with differential demand. Let us say this is our first time period cycle. Then we have a short cycle. Then we have a large cycle like this. This is a differential rate of demand This is your inventory level represented by Q. This is your time period represented by T. Now, if you look at this here, the time T1 is different and the time T2 is different and time T3 is different. So, differential demand, different rate of demands in different cycles. Different rates of demand in different cycles. Okay, so when you have this scenario of differential demand with different time limits, the formula for economic order quantity Q star is equal to root of 2 into D into CO divided by CH and T divided by CH into T. And total inventory cost would be root of 2 into D into CO CH into P. And this is your total inventory cost. So total cost is equal to TC star plus cost of material. Total cost is equal to TC star plus cost of material. So different rates of demand. I am looking for formula problem. EOQ unknown demand. Uncertain demand. happened to uncertain demand? I had a problem. Eoq model with different rates of demand. Uh, So we are not able to find a problem with different demand. Even this ICMAI, let's see if I can get it. Okay. So you remember these formulas. I'll try to get a problem where we can look at these different cycles of demand based on the time period. Okay. All of you got the formula? Now let us look at economic order quantity EOQ when shortages are allowed. When shortages are allowed. So when there is a shortage allowed, so the graph will look like this. So this is your inventory level. This is your what we call time period. Now the thing is, there is a shortage which goes down the level, and then it becomes a straight line. It becomes a straight line. And again, it goes to the shortage. again it goes, and again it comes to the thing. So this we call it as shortage. So if you look at this period, we call this as shortage period. This is your shortage. So we will have shortage. This is your shortage time. And every time we will, when there is a shortage, these shortages are allowed for demand, right? So this is the situation where shortages are allowed. Okay, so when you have shortage cost allowed, there are what you call the formula would be different. The Eoq formula or the Q star formula, when there is shortages, is equal to root of 2dCO by CH CS, cost of shortage plus cost of holding divided by cost of shortage. So when shortages are allowed, this is the formula. Into, that is into only, right? So this is the formula for allowed shortages. So TC star, total inventory cost is equal to root of 2 into D into CO CH into CS by CH plus CS. And cycle time T star is equal to Q star divided by D. D is the demand.
So here we are ensuring that the demand is uniform, right? But it is allowing for shortage.
It is allowed for shortages. Shortages are allowed. That means you can
And,
order only after the product is completely over.
So here demand is uniform only, right?
Not uniform, no? Demand also will slightly vary. Demand will also slightly vary. It is not a constant demand scenario. See, because of unevenness of demand, that's why the shortages are there, no? See, if you know the demand, constant demand rate, where will be the chance of shortage? Got the point?
Yes, sir.
So basically, the shortages happen because of the fact that the demand is inconsistent. Similarly, the maximum inventory level M star is equal to CS by CH plus CS into Q star. All right. So this is the maximum inventory level M star. So let us look at the problem. Truck engines to be supplied at the rate of 20 per day. Truck engines to be supplied of 20 per day. The penalty in contract is 100 per engine per day for missing the scheduled delivery date. For missing the scheduled delivery date. Cost of holding an engine in stock. The cost of holding an engine in stock for 1 month is 150. So the production process is 30 days. So what we have to determine is determine the maximum and determine the maximum inventory level. Determine the maximum inventory level. All right. So let us identify the parameters. Cost of holding is 150 by 30, 5 per day. Cost of stock, cost of shortage. Cost of shortage is 100 per day. Cost of shortage is 100 per day. Demand is 20 and the time T star is 30. Now we have to find out the maximum inventory level. We have to use this data to find the maximum inventory level, which is M star. So M star is equal to CS by CH plus CS into formula of Q star is root of 2 into D into CO by CH into CS by CS plus CH. So replace the values in this formula and then you'll get the answer.
So CS is cost of shortage, right? CS is
Shortage.
cost of shortage, right?
Cost of shortage. So if you solve this, CS is 100 by 5 plus 100 into root of 2 into 20 divided by CH is what? 5, right? Into 100 by 100 plus 5. So 100 by 105 into root of,
Sir, can you once scroll up?
yeah, I'll scroll up. 2 into 20 is 40, 8 into 100 by 105. 1 second, let me solve.
Sir, I'm asking you to scroll up because I think Q star is root over 2D CO by CH into CS plus CH by CS. So you have it has to be 105 by 100. You have done opposite.
It is only CH, right?
Yes, sir.
I don't know, I put only CH only, no?
Sir, it has to be 105 by 100. It is CH plus CH by CS.
Okay, reverse. Okay, got it. CS plus CH divided by CS, right?
Yes, sir. Sir, also we have not mentioned C0.
There is nothing, it is not given in the problem.
So what will take?
Just like, we don't take it into consideration.
Okay, sir.
So 0.95 105 by 100 is 1.05 into 8, 8.4 and 8.4 square, which is 2.89. So into 0.95 2.765. So we made some mistake somewhere here. Okay. So we have T star, right? So actually we are using wrong formula here. I'm sorry, we have to use the other formula because we don't have CO here. That's why we are not able to calculate. Sorry, just correct myself. We have used wrong formula. The formula is CS by CH plus CS into Q star, right? Which is equal to CS by CH plus CS into demand into T star. Demand into T star, because if you see here, one of the formula is T star is equal to Q star by demand. So we will use that formula. That way it will be easy. So the final formula is cost of shortage is 100 divided by holding cost is 5 plus 100 into 20 into 30. So 100 plus 105 into 20 into 30, which is 100 by 105 is how much? 0.9523 into 600. 600 into 0.9523. Round about 571 approximate. So we can maintain 571 engines as maximum inventory. We can maintain 571 engines as maximum inventory. All right. All of you got this? Okay. Can I move forward, participants? Now let us do a problem where we will use the original formula. We will use the original formula of this EOQ with carrying what you call cost of ordering also. So let us do a problem with demand is 10 engines per day. Shortage cost is equal to rupees 90 per day per engine. Carrying cost rupees 140 per month. Ordering cost rupees 150 per order. Now, sorry. Now let us calculate EOQ using this original formula. Calculate EOQ using the original formula. So what was the formula? EOQ is equal to root of 2 into T into CO by CH into CS by CS plus CH. Use this formula to solve this and give me the answer. So I think I again reversed it. Okay, CH1, CH plus CO by CH. CH plus CO by CH. Why the formula? I'm getting confused with the formula. Is the formula right? So the formula here, CS plus CH by CS. So this should be root of 2 into 10 into 150, right? Divided by 14 by 3 into 90 divided by 14 by 3 into 90. This is per day into 30. So if you take this whole thing down, root of 20 into 150 is 3000. 14 by 3 is
Sir, are you calculating for month, right?
we are calculating per month. Yeah. Into 643.77 into 90 divided by 409 0.214. So is root of 643.77 into 0.214 137.76. 137.76 into 0.214 11.73 into 30. Okay, what is the final answer you got? I made some mistake somewhere there.
Sir, what is the shortage cost?
This is not multiplication, right? This is plus, right?
So,
Yeah, I made a
uh,
mistake. That's what I made some mistake somewhere. This is 14 by 3 plus 90, right?
sir, also the formula which you have given, there it is CH plus CS by CS.
No, no. The formula is this, right?
Sir, in the note which you have given, no formula.
CS plus CS by CS.
Yeah, yeah. But in the problem you are doing opposite.
Uh, all formulas are going wrong. I have given this formula, right? CS plus CH by CS, right?
Yes, sir.
So we'll go with this formula only. That means reverse formula, right? What is the cost of shortage? 14 by 3 plus holding cost is how much? $90. By, this is CH only, right? Is this correct?
Sir,
What
I'm
is it?
getting the answer as 26.
Into 30.
Okay, sir. Actually, some difference will be there because of point.
Ah, okay, that's okay. 26 into 30 is how much?
Sir, this thing, sir, this demand is 10 into 30, that is 300 per month, right?
Per day, yeah. No, we have made
Sir,
everything per day, right?
so you are doing it per day.
Okay, that's why I'm dividing it 14 by 3, 30, right? 140 by 30. I have made everything per day only.
Okay,
That's
so
why,
you are calculating EOD per day, EOQ per day.
EOQ per day into 30.
Sir, but in the problem, carrying cost is given per month and ordering cost is given per order.
Everything is per day, right? See, very clearly, every 10 engines per day, demand is per day, shortage is per day, ordering cost is 150 per order per day. We can assume it as per order per day, right? And then the only metric which is per month is this. That's why I converted instead of converting all to per month, I have converted this into per day. Got the point?
Okay, sir.
And I will multiply it with what you call 30 so that we can get the lot for the month. So this would be 3000 divided by 4.66 into 94.66 divided by 4.66 into 30. So that is equal to 3000 by 4.66 is how much? 643.77 multiplied by 20.31 into 643.77. That will become into 30. This will become root of 13,077.09 into 30. So this will become 114.3 into 30. 3,430. All right.
Sir, your Eoq formula is CS plus CH by CS, right? Also, you have taken CH as numerator. It should be CS.
It has to be
CS, shortest cost. Like it will be 14 by 3 plus 90 divided by 90.
this one.
Yeah, there only. It will be divided by 90. It
Right?
has to be CS. Sir, in the formula you have given it is
Okay.
CS
Denominator is wrong, right?
by CS. Yeah.
This will be 90, right?
Yes, sir.
I'm making so many mistakes today. What is happening? Oh. 24.66 divided by 90. 1.051. 1.051 into
We are getting 26 only
0.77.
per day.
This would be root of 677.10. 26.02, right?
Yes, sir.
26.02 into 30.
78.
780, yeah. 780 units. Correct. All right? All of you got this? Okay, all of you got this? Shall we continue? Now let us look at Eoq with discounts. Eoq with discounts. This is a little bit complicated. The formula is Eoq is equal to root of 2 into CO into D divided by I into Pn. I is equal to, if you look at I, inventory charge, Pn is equal to discount. No, purchase quantity. Purchase quantity is Pn. So Eoq P2 into COD by I into P into N. Right. So you have to calculate it multiple times for different quantity, and then we have to calculate the total cost. The total cost TC is equal to P into Pj plus CO D Qj plus 1 by 2 into CH and Qj. And CH is I into Pj. So these are the formulas for Eoq with discounts. So we will solve this using a problem. Annual demand for an item is
Sir, what is PJ?
percentage change. Percentage change. So the inventory carrying charge, is 24% of purchase price per year. Purchase price per year. Now purchase prices are P1 is equal to 10 for purchasing quantity less than 500. Purchase price 2 is equal to 9.25 for purchasing 500 less than equal to Q2 less than 750. Purchase price P3 is equal to 8.75 for purchasing 750 less than equal to Q3. So these are the purchasing prices for different quantities. Determine optimum purchase quantity. Determine optimum purchase quantity taking the order cost as 1, 437.5 and 2, 87.5. All right, all of you got the values? Now let us calculate Q3 star as 2 into 437.5 into 2400 divided by 0.24 into 8.75. So if you take this root of 2 into 437.5 into 2400 is equal to 21 lakh. No, there's something. 2 into 437.5 is equal to 875. 875 into 2400. 21 lakh. 21 lakh divided by 0.24. 8.75. 1 second. 2.1. That means root of 21 lakh divided by 2.1 is 10 lakh. Yeah, tell me. That means 1000 units.
Sir, your quantity 437.5. Okay, okay. Sir, how are you? We are purchasing 2,400 units.
Yeah.
That's why it is 8.75. Okay.
Pardon?
No, sir, I got it.
See, there are two ordering costs. One ordering cost is 437.5, one is 87.5. I am calculating the purchasing quantity for Q3 at price 3. I am ordering the quantity at price 3 with ordering cost of 437.5. Got it?
Yes, sir, got it.
So, for Q3, the optimum quantity is 1000 units.
Sir, why are you calling it as Q3 star?
Because we have taken price 3, na? This is what, 8.75. Because we got, I assume 1000 units.
2,400.
150, right?
Yes,
Right?
yes, sir, yes, sir.
Got it?
Yes, sir.
Now, if the ordering cost is less, that means the quantity will also be less. So Q2 star is equal to 2 into 87.5 into 2400 divided by 0.24 into 9.25. Oh, sorry, into 8.75. So let us calculate 2 into 87.5 into 2400 is equal to 4,20,000 divided by 0.24 into 8.75, 2.1. 4,20,000 divided by 2.1 is equal to 2 lakh. Root of 2 lakh. Square root of 2 lakh is 447 units. Now, 447 units, we have a problem here. 447 units means the price cannot be 8.75. What will be the price if it is 447 units?
And
9.25, right? 9.25, right?
sir, if it is 447, then it quantity is less than 500. No? So it has to be 10.
We have to take 10 rupees, right?
Yes, sir.
So we will compute 418 units. So the price would be Q1. 2 into 87.5 into 2,400 divided by 0.24 into 10, right? So root of 4,20,000 divided by 0.24 into 10. 2.4. So 4,20,000 divided by 2.4, root of 1,75,000, which will equate to 418 units. So 418 units. Okay. So the optimum quantity to purchase would be 750 units, right? Because we are seeing the optimum purchase unit total cost. We have to calculate total cost. So to decide this total cost, if it is 418, it would be 10 into 2,400 plus 87.5 into 2,400 divided by 418 plus 1 by 2 into 0.24 into 10 into 418. So 10 into 2,400 will be 24,000 plus 87.5 into 2,400 2,10,000 divided by 418 is 502.39 plus 0.24 into 10 into 418, 1003.2 divided by 501.6. So this would be 25,000 45, 25,003.45. Let's into usage. Alright, all of you got the answer? Similarly, can calculate for 750 units also the minimum purchase quantity for 8.75. So if you take a TC of 750 units, which is 8.75 into 2400 plus 87.5 into 2400 by 750 plus 1 by 2 into 0.24 into 8.75 into 750. So 8.75 into 2400 21,000 plus 87.5 into 2400 divided by 750. We got 280 plus 0.24 into 8.75 into 750 divided by 2, what 787.5. So this will become, so 21,000 plus 280 plus 787.5. So we got 22,067.5. So the optimal quantity to buy is 750. So it is better to buy 750 units at a minimum price of 8.75. That is your total inventory cost. So the last is the best purchase cost. All right, participants?
Yes, sir.